Welcome back to Workshop Friend. Having just completed a few projects on my milling machine, I thought it was about time that I returned to one of the lathes, and today I'm going to be working on the Colchester student lathe. And this is a job that I've been meaning to do for some time. Now, I've never had a saddle or a carriage stop for this lathe, and I've wanted one for some time. Up till now I've managed by clamping a piece of stock to the bed, but it's really not very convenient. Now, there are available online second-hand carriage stops for this lathe, but they're ridiculously expensive, and I thought it would make an interesting project to make one anyway. I'm going to use a piece of 2-inch mild steel round stock, which seems to be about the right size, and it will clamp in this position here. I'm going to make it so that I can use it on both sides. On this side it would be used as a stop, and on the other side I might use it with a DTI. Now, I do from time to time use a DTI to index the saddle. Until now I've just done that by holding off a magnetic base, but it's really not very convenient with this style of bed. So I'd like to have a feature on the carriage stop which will hold a DTI. I was thinking about having a thimble style adjuster on the carriage stop, but I really don't think that's necessary. I think a feature to hold a DTI and a combination of the top slide will really make that feature redundant. I didn't want it just to rest on the two flanks of the V with a locking feature underneath, because there is a tendency for the whole thing to want to rotate. To resist that rotation, what I'm going to aim for is location on two flanks of the V and the front face with the locking feature underneath. That will give a more positive location, and also if I make it long enough it will make a more stable carriage lock which I can index along if I ever want to use gauge blocks. Now, to ensure location on these two flanks and the front, I need some good measurements. The way I went about that was to use my smallest V block with this bit of stock in here. It's a nice fit, and then I use my depth micrometer to take a measurement of the front face. The second measurement was with a gauge pin and measuring from the same face. So those two measurements I transferred to my CAD drawing, and that gave me the fairly precise dimensions of the two flanks of the V in relation to the front face of the bed. That was the first part of my layout, and hopefully that will enable me to achieve a bed stop or a carriage stop that won't rotate. Also, having good dimensions will hopefully minimize the amount of trial and error I have in getting this to fit on the bed. So I'm carefully setting the parting tool and locking the carriage to part off 2 inches of stock. I put some considerable time and effort into making this rear mounted tool post, which I'm now using for parting off, and I thought I had solved the problem of parting off, but as you're about to see I had another foul up, but I think I know what the reason was. Okay, after that nasty foul up, I've reground the parting tool and brought it out just over 1 inch, so hopefully we can get right the way through, and I'm just taking it very carefully. I could hear a change in the sound of the cutting towards the end there, so I thought that last little bit I'm not going to risk it. I'm just going to cut that off with a hacksaw. Just in case you think that the chuck wasn't fully tightened, you can see how the jaws have really dug into the material there. Now, I've thought a little bit more about the setup I'm going to use, and for machining this slot in here, I'm going to use the vertical head. So I'm going to come in, machine these surfaces, and then rotate the head 45 degrees and come in this way. So I figured the best way of doing that is to do this in my smaller vise and sit the work on a parallel, or a couple of parallels. So I'm going to put a couple of slots in the rear, and that will just ensure that the work sits lower in the vise. So I just have enough clearance there to machine this out without touching the top of the vice jaw, so they give the maximum possible seating area. The other feature of this, it will enable me to index it around to get this vertical for boring. So I'll use this slot as a measuring device for when I need to rotate it 90 degrees. So I'm going to go ahead now and machine these two slots. Just touching off the top there, that's a 2/1000 gauge, and then we can work out how far to bring the table up. So the square is clamped to the work in the slot, and I'm using the DTI to tram the square. The position of the cross hole relative to the slot, which will be machined later, is actually quite critical. So I'm carefully measuring from the diameter, again using a feeler gauge, and also from the end of the work to get the true center line. And even though I took some care over this, you'll see in the next video that I didn't get it quite right and I had to make a slight adjustment. I'm counterboring the seat for the bolt head, and there's a bit of chatter here, and that's because this tool is actually flat bottomed. I couldn't be bothered to regrind it. And now at last center drilling for the bolt hole. Now, because my mill is actually a horizontal mill with a vertical milling head, I don't have a lot of height. So for these kinds of operations, I transfer the work in the vise to my pillar drill. Good, that's centered over the hole now, so we can remove that and put the boring head back in place. So without disturbing the work in the vise, we're back on the milling machine, and I'm now counterboring for the head of the bolt. Okay, I've reversed the component, put it upside down, so we're going to bore from this top surface, or the bottom I guess it is, and I put the square again on the slot there, and I'm just tramming it up. Actually, it's not as difficult as it looks. Okay, the problem we've got is that I don't have enough height on my machine. I can't bring the tool out anymore. Really, I need to reduce the length of this shank here. It doesn't need to be that long on my machine, but that's not a job for now. Well, with some difficulty, I've set this up in my 4-jaw chuck using soft jaws, which actually makes this a little bit more difficult. I've got it square with the axis of the machine this way. I've got it reasonably square this way, but not finely as I want it. And I've got a bit of a problem here. I picked up this bore. That's reasonably concentric, but the drilled hole isn't. And that could be for two reasons. It could be that there's some malalignment between the center that I took from the top and the one I've machined from the bottom, or it could be that the drill's wandered, or it could be a bit of both. So what I'm going to do is rough this out in this setting. I'm going to drill this out almost to depth, and I'm going to make a little spigot that goes in the end there, so I can actually pick up the center of the hole at the other end, which is what really matters. Incidentally, you're probably going to see the drill wander a bit because that central hole isn't running concentrically, but we're just roughing out at the moment. Okay, I'm just roughing out the hole. This is really where I could do with a saddle stop, but anyway, I'm managing with this blind hole, and I'm just taking it as close as I can to the final size before finishing. Basically, I want to get down to the bottom of the hole there so that I can put my little gauge in to measure the concentricity of the hole at the bottom there, the clearance hole for the bolt, and also just so I can see what I'm doing. Well, I made up this little arbour here, which got a nice fit on in the hole, and of course it's going to go right to the other end. I'll put a centre in the end here as well, and then we can use this to see how much run out there is, how much real run out there is. Okay, we've got a total run out now of 15 thou, which is quite a lot. So what I'm going to do now is I'm going to adjust this, and I'm going to center on this, and at the same time measure, ensure that this is parallel with the axis of the lathe. Once I've done all that, I can try boring this out. If you look carefully beneath the chuck and in the background, you can see my mock-up of a saddle stop made from stock and a G-cramp, and that's of course what this project is to replace. Okay, that's come out quite nicely. I'm pleased with that. It's to the right depth and the right diameter. Hopefully it's also square. I'm now turning my attention to the cotter, which is made from mild steel. Originally I was planning on brass, but I thought with the potentially thin wall that would be left behind, steel might be a better option. Having recently acquired some new collets and modified this Bernard collet chuck, it's great to be able to use it on stock material like this. It really is coming into its own. I'm drilling here, ready for tapping 5/16 UNC. Okay, the nut's now finished. It's deliberately too long. That should be the place where it ends up, but obviously with the clearance at the bottom of the hole. But the reason I made it too long is so that I can put the bolt in the end here, tighten it up, and then I can mill out this slot, and automatically it will profile the cotter. I called it nut just now, but it's a cotter, isn't it really? So that profile will automatically be milled out when I mill the whole block. What I'm going to proceed now with is the bolt. So it's a 5/16 UNC bolt with a square head, and I'm going to turn it on the Myford lathe, cut the thread, and then finish it off with a die, and then take it over to the milling machine to put the hex head on. And I'm cutting it from silver steel so that I can harden and temper it. So having cut the thread and chamfered appropriately, we're going to take this over to the dividing head in the milling machine. Back to the lathe for facing the head to length and adding a nice chamfer. Okay, after tidying up with a file, here is the bolt and the cotter that it goes into, and the cotter will go in there, and the bolt comes in the top. Now I've left a little counterbore there so that this neatly comes down flush like that, and the reason for making this style of head is that I can use my universal spanner, which fits the other features on my lathe, to tighten this up. So I think this is a convenient point to stop. Next video we'll finish this off. There's a few operations yet to do, and of course the most interesting one I think is going to be cutting out this slot. Thanks for joining me. I hope you join me next time.